we have Tuesday and Wednesday. So understand the difference between R being read, W being write, which overwrites, and A being append, which allows us to append a file instead of overwriting a file. So that is it for this lesson. I'll go ahead and see you over in the next one. All right, let's talk about classes and objects. So Python is what is known as an object-oriented programming language. So pretty much everything in Python is an object. And we can use what is called a class to be what is like an object constructor. And we can use that to help create objects. And this is a little bit easier to explain once we actually demonstrate this. So we're going to create a couple of files in this lesson. And the first thing that we're going to do is we're going to do a mouse pad, and I am going to create a file called employees.py. And in this, we're going to go ahead and declare a class. I'm going to save this here. So let's do class employees, save it. And we're going to go ahead and hit enter and just tab over. And we're going to do this define and 2 underscores, init or init, 2 underscores again. And we're going to put some parameters inside of this function. And we'll talk about what the init function is here in a second. Let's go ahead and let's think about having employees. So the first parameter we're going to define is called self. And then for our employees, we might want to know the employee's name. We might want to know what department they work in. We might want to know their role in that department, their salary, and maybe the years that they've been employed. So we'll do years underscore employed. And just like a function, we'll add the colon here at the end. And we're going to go ahead and tab. And then we're going to define all of this. So let's go ahead and say self.name is equal to name. So we're creating methods here, which you'll see us use in just a bit. We're going to do self.department equals department. And you should get the gist at this point. Self.role is equal to role. Self.salary is equal to salary. Self.years employed is equal to years employed. Okay, so let's save that. So all classes have a function called the init function. And this is always executed when the class is being initiated. So we're going to use this init function to assign values to object properties. So what we're doing here is we're creating these parameters within this function, and we're also building out methods that we can use once we import this class. So let's go ahead and close this out, and we're going to open up another mouse pad. And we'll just call this something like our employees.py. You can call it whatever you want. And I'm going to go ahead and do my shebang at the top. We'll do bin python 3. Save that. And from here, I want to actually import the class that we just built. So what I'm going to do is I'm going to import this, and we're going to say from employees import employees. All right, and we can make a couple of employees here. So let's set a variable of E1 for employee 1, and we'll just do employees. And I'm going to stick with the Bob's Burgers theme from earlier. We'll just say we've got Bob. Remember, we're declaring Bob's name. His department, we'll say he works in sales. We'll say that his role within that department is the director of sales. And we'll say his salary is $100,000 a year, and that he has been employed for 20 years. And we'll do another employee, and we'll say that this employee is Linda. She is an executive. She is the Chief Information Officer, or the CIO. She makes $150,000 a year, and she has been with the organization for 10 years. So we can do some stuff with this. We can go and say like print e1.name. Let's save this, make sure everything works. Come in here. Actually, let me close and reopen this because I forgot my ampersand on this. And we'll come back, and now we'll go ahead and do Python 3 r employees. And you'll see that print e1.name is pulling down Bob. So we're using the name method that we created with our class. So we define that within that class. So now we have the ability to pull down information based on the class that we built. So we can also do something like print e2.role, and we should get that role printed out for us. So if we see e2 role, we're getting that she is a CIO. So that is accurate statement here. Let's see if we could open both of these. Let's open also employees.py, and we have both of these here now. So it's a little bit easier to see. We've got our function, our init function here, and we have all of our methods that we've defined. Now we can build upon this within this class. So let's say if we wanted to make another function, if we wanted to say something like define eligible for retirement, and we just said self in here as the parameter. What if we said something like if self.years employed is greater than or equal to 20, then we return true, because if the person has worked with us for 20 years, then they are eligible for retirement. Otherwise, if they haven't, then they haven't earned their retirement yet. So we can look at an employee and see how long they've worked with us, and we can save this here. And then we can come in here, we can do something like print, and we'll say E1, and we'll ask if they are eligible for retirement. Okay. Save this, print this out, and you'll see that Bob is indeed eligible for retirement because he has been with the company at least 20 years, which is what we put here within the class. So just know what we're doing is we're building out our own class, and we're able to define these functions and these parameters, and these help us with creating our objects that we're using over here. So we've got our classes, and then we've got our objects. So this can get really robust very quick, and we'll build out a project to look at that here in the next lesson, and that way we can tie this all together. But this is a very important part of programming, and this is very much a 101 class, so we're just skimming the surface on what this is. But this is actually incredibly useful when we start building out classes like this to help with other things that we're writing and pulling information from. So that's it for this lesson. We're going to go ahead and move on to the next one. We have reached the final project in this course, and this is going to tie everything together that we have learned thus far. So I am a bit of a sneakerhead, which means I really like shoes. And so what we're going to do is we're going to build a budget app using classes and objects, and we're going to see what shoes we can afford based on how much money we have. So we're going to go ahead and start with the class, and we're going to just make a new file. We'll do mousepad, and we'll call this shoes. I can type shoes.py, open that up, and we'll also open up a new window as well, or just a new tab here, and we'll write in both of these. So for this one, we're going to go ahead and just define a class of shoes, and I'm going to go ahead and just save that so I see the colors. And here we're going to define our init statement, and we're going to just say self, and then we're going to have a name, our name of our shoe, and the price of our shoes. And within this, we're just going to define self.name equals name. This should all look familiar so far. And self.price is equal to price. What we're going to do with the price, because we'll run into an instance where this is going to be taken potentially as a string, we're going to go ahead and just give this a float. We want to make sure that we are assuming this is going to be a float of a price here. let's go ahead and define a few more things. So I want to define a budget check. And I want to make sure that we have the budget here. So what we're going to do in this instance is we're just going to say self, and then we'll also add in budget here. And we'll come in here and we'll do a check first. We want to make sure that we are given an integer or a float here when we are asked for the budget. So we can say something like if not is instance. And what this means is we're saying if this type is not what we're specifying here, then we're going to go ahead and reject this and close out of the application. So the is instance looks for a type and returns a true value. But if we say is not true, then that's false. Remember our truth tables, and thus becomes invalid and closes the app. So what's going to happen is we're going to say budget, and we're also going to look whether budget is going to be an int or a float. And if it is not one of those two things, we're going to go ahead and print out invalid entry. Please enter a number, something along those lines. And then we'll exit the application. So let's say that we have a budget and we want to also know how much money is left over if we buy the shoes. So we can define something like change, or what change is left over. And we could say something like self budget on this as well. And we can just return our budget minus our self.price. So remember, we declared self.price up here. Now we're calling it and we're just saying, hey, I want to return the value of the budget that we have minus the cost of the item that we're purchasing. Okay, only a couple more things and we'll be done with our class here. So we also need to purchase it, right? So let's define buy, and we're going to do self budget again. And here we're going to do a self.budget check. And we'll check our budget. And what we'll say is if our budget is greater than or equal to self.price, then we're going to print out. We'll do an F string here, and we'll just say you can cop some, and then we'll do self.name. So the name that we'll provide here. This will all make sense once we tie it all together. Okay, and then if our budget is equal to the self.price, then we're going to just say print out you have exactly enough money for these shoes. Otherwise, we can do else. Now we could go through this whole thing and give a statement and say, well, what if we had no money, or what if we didn't have enough money? But in this instance, we're just going to print out the situation of you can buy these shoes and have, we'll give a $sign here. We'll say self.change, and we'll give a budget left over. So we'll say left over, just like this. All right, and then when we exit the application, we can say something like exit, and we'll just give a statement, thanks for using our shoe budget app. Now, this might not make any sense yet, and that's okay. Let me make this a little bit bigger. And so what we're doing here is we're defining our init, and in our init we have a name, which is going to be the name of the shoe, and a price, which is going to be the price of the shoe. So self.name is equal to name, self.price is going to be a float because we're expecting, potentially it could be our price of our shoe could be $2.99 or $100.99. It might not just be a perfect number, so we want to use a float. We have our budget check here. We're just checking the is instance. We could, in theory, add to this budget check and make sure we have enough funding before we come down and do the purchase. Would probably be the logical way to do this. But in this instance, we're just using really beginner logic, and we're just coming through and we're just saying, hey, if this instance isn't an integer or a float, like somebody types in a string, then we're just going to go ahead and reject this. We don't want any, we have no interest if this is no integer or a float here. Then we're going to define our change. So if we have money left over, like if we have budget minus the price of the shoe, then we're going to go ahead and give some money back. And then we're going to buy the shoe as well. So we're going to have our buy option. As long as our budget is greater than the price of the shoe, we can buy that shoe. And if the budget is equal to the price, then we have enough money. If it's not, then we'll actually have some money left over here. Unless it's the instance of not having enough money, and then it'll just exit the application because we haven't told it to do anything else. And then it'll also thank us for using the shoe app. So that's part one. We have defined the class. Now, could we build this out all in one thing? Yes, we could just write a script out for this. We could code this and make it into one easy script. But what this will do is allow us flexibility. This is where object-oriented programming comes into play, because we don't have to continue to repeat ourselves. And what we're following is what is called the dry approach, the don't repeat yourself approach. And so what we're doing is maintaining everything in a class here, and then we'll call that class and make it very easy on us instead of having one crazy long script that is potentially repetitive and a lot more difficult to go through. So here we're going to just open this up, and I'm going to call out a shebang on bin Python 3. I'm going to save this, and I'm going to call this shoe purchase.py. Save that. Now, we're going to import from our class that we made. So from shoes, import shoes. And let's define a few variables. So let's say low is equal to shoes. And for the low price shoes, we're just going to say we can buy some and ones. And we can buy those for $30. For medium price shoes, maybe we can purchase some Air Force Ones. And for those, maybe they're $120. And then for the high price shoes, maybe we're interested in purchasing some Off-Whites. And those might run us $400. And from here, what we're going to do is we're going to do a try statement. Remember, we've done a try statement before. And we're going to say try. And we're going to say shoe budget is equal to a float of an input. We're going to ask for an input here. So this is all tying together. We'll say, what is your shoe budget? Do a question mark there. Tie this together. And then we're going to do an exception. So if we have a value error, meaning we don't get a number back, similar to what we were doing previously, if we don't get a number back here, we're going to say, please enter a number. Now, we can come in here and say, for shoes in, and then we can just give this high, medium, low, like this. We can do a shoes.buy. And remember, we came out with this buy method over in our class here. So we're doing a shoes.buy. Going to go ahead and check all this for us. And we're going to say shoe budget. So we're going to take the input of shoe budget. What's the value here? We'll take that. We'll come in here and we'll see what our budget is. If it is greater than or equal to the price of the shoe, we're defining our name of the shoe and our price of the shoe from our parameters that we defined up here, name and price. So we're saying, hey, the name and the price. So is the price of the shoe, is it at least the amount of our budget? And if it is, we can buy that. And we'll check in the highest order and then go in the lowest order. If you flip these and you put in $400, it would just keep telling you that you can only buy the low price shoe. So you need to make sure it's in the highest to the lowest order in this example. And So it'll check, do we have enough money to buy the $400 pair of shoes? No? Okay, and then do we have enough money to buy the $120 pair of shoes? No? Do we have enough money to buy the $30 pair of shoes? So we'll go through that and iterate in this loop to see what we can or can't buy. So let's go ahead and save this, and we'll save shoes.py, and I'm going to go ahead and run this. Hopefully I have no typos. We'll do shoe budget, shoe purchase, sorry, and run this, and I do have a typo. And so if I come back in here, I forgot to close off my F string, so let me save that. Now let's try this. What is our shoe budget? So let's give it a few different options. If we said our shoe budget was $30 exactly, well, it's going to say that we can cop some and ones, and we have exactly enough money for these shoes. Thanks for using the shoe app. What if we had $31? Well, we could still cop some and ones, and then we can buy these shoes and have $1 left over. All right. What if we had $450? Well, we can buy the off-whites, and we can buy those and have $50 left over for our budget. So hopefully this makes sense. I know this is a lot of information, and this, again, is just a 101 course. So we're just kind of dabbling in the object-oriented programming. And if you continue on with Python from here and you start getting into more complex material, then you could build upon what you're learning here. So try to think of something that you might want to script out like this or write out like this, and think of the logic behind it. I highly recommend going and doing coding challenges or programming challenges and try to increase the logic and the ideas behind what you're trying to build. And that just takes practice. All of this takes practice. It's one thing to watch and follow along with somebody. It's a whole nother game to go out and do this yourself. So start thinking of some things that you want to build. Really use your Google skills. Look at Stack Overflow and look at some Googling and some Redditing, and just try to piece together the logic that you have in what you want to build. So highly recommend building upon this. This is a great language to learn and very flexible, and I hope that you continue on with this. Okay, before we get hands-on, I have to give you a little bit of death by a PowerPoint, but it's for good reason. So we need to introduce the 5 stages of ethical hacking. These are the 5 stages that you will go through on every assessment. So before we do that, let's first make a big note. From here on, we are moving into the ethical hacking portion of our course. We're going to learn malicious things. Please only use the information learned in this course for ethical purposes. Do not attack your neighbors. Do not attack anybody that you do not have explicit permission to do so. You can and will get into trouble for doing that. So with that out of the way, let's talk briefly about the 5 stages of ethical hacking. So we start up at the top, and we actually start with what is called reconnaissance. This stage is also known as information gathering, and there are 2 different types. There's active and passive. Now, passive is saying, like, going out to Google and searching for somebody. Say you're given a client and you want to look at their Google, you want to look at LinkedIn, you might be looking for, I don't know, a picture of their badge or an employee's name, or maybe an employee's Twitter page. That's all passive. You're not actually going out to the company's website and doing anything active against it. Now, active reconnaissance kind of falls into place with the second phase, which is scanning and enumeration. Now that is active. That is where we go out and we take tools such as Nmap and Nessus and Nikto, and if you've never heard of any of those, that's fine. But we take those and we scan actively against a client. Now what we're looking for are open ports, vulnerabilities, different items. And with what returns on these results when we do this scanning, we also perform what is called enumeration. Enumeration is just looking at items and digging into them to see if we can find anything of value. Say that there is a web server running on port 80. We see port 80 is open and it's running something like Apache 1.2, which would be really, really outdated. we would go out to Google and we would say, Google, do you know if Apache 1.2 has any exploits for it? And we would do research. That's the enumeration portion of it. So once we do our information gathering, we do our scanning and enumeration, then we move into the gaining access portion. This is also known as exploitation. We will run an exploit against the client or against the vulnerable service or whatever it may be to try to gain access into a machine or into a network, into an environment, etc. Once we have that access, the process starts to repeat. We do scanning and enumeration again, and we also want to maintain that access, right? So if we were to get kicked out, okay, or a user shuts down their computer, how do we maintain that access so when they turn their computer back on, we still have access to it? And then lastly, there is the covering tracks. You want to delete any logs that you may leave behind. You want to delete any kind of malware that you upload, which is more important as a pen tester. Any accounts that you create for any reason, you want to delete those as well. You really just want to clean up, is a good way of putting it. Covering tracks is the more hacker way of putting it, but as a penetration tester, you really just want to clean up. So we're going to go heavily through steps 1 through 3 in this course. We'll also cover 4 and 5 briefly, but the process and methodology never changes, regardless if you're doing network, if you're doing web app, or if you're doing a different type of assessment. It's all similar in this 5 stages of hacking. The tools might change, the attack methods might change, but the overall methodology is always the same. So that's how we're also going to structure this course. We're going to go in first and we're going to talk about information gathering and reconnaissance. Then we're going to move into scanning and enumeration, and then we'll start with exploitation and do that repeatedly till we get it inside of our heads and it feels almost second nature, right? Once we have all that done, we'll do some practice boxes, give it a go, see how we do. We'll move into the internal side of things with Active Directory. We'll start working with our web applications and our wireless, and we will touch on the maintaining access and covering tracks, but you're going to see this methodology over and over, and you might also get this question on an interview, to describe the 5 stages. So it's important to know these. It's just something that every ethical hacker can rattle off pretty quickly. So have this written down, think about it, keep your wheels spinning, and let's go ahead and move on to our first section, which is going to be information gathering / reconnaissance. Let's learn some cool tools, some Google Foo, and just what kind of information we can actually gather on a potential client. So in this section, we are going to be talking about information gathering. And all the information gathering we're going to do in this section is going to be passive. So I'm calling this passive recon or passive reconnaissance. I wanted to give a brief overview of what we're going to be covering and talk about some high-level topics before we get into the weeds and really dive into our target. So let's talk about the different types of passive recon. So on the physical or social sides, physical meaning actually going on site and maybe doing a physical engagement, or the social engineering aspect of maybe doing a phishing assessment or even including it in a physical engagement or a phishing assessment. Just gathering this information from the physical social aspect is incredibly useful. So we have location information. So we might utilize something like satellite images, or often we'll go on site and do drone reconnaissance where we fly a drone around and try to gain information. And what we're really after with these images of this drone recon is we're trying to find out, hey, what does the building layout look like? Are there badge readers? Are there break areas? Does security exist? Do they have somebody posted out up front? Can you just walk right in the door? What does their fencing look like? Are there areas where they're just leaving the doors propped open? Where do people go out and smoke in these break areas? Because those are a good place to just walk up to somebody, light up a cigarette, even if you don't smoke, and just start a conversation, and then tailgate right in with them into the building. Now, the other aspect of this is the job information. So we might be looking for employees online. I might want to know somebody's name, job title, phone number, who their manager is.
I try to get a good idea of what people look like. So if I see them on site, I have a good idea who they are. I also look for pictures. So I cannot tell you how many times a badge photo is posted on LinkedIn or somebody posted on Twitter. You could see all the memes out there about people posting their photos at work, and it's bad. It happens all the time. I see it to this day. So we're looking for badge photos. I'm looking for desk photos, computer photos. I had a situation once where somebody took a picture of her watching a game at work. She was watching a basketball game at work, and the basketball game was on her computer, and on her screen there, it showed all the different tools that they utilized at work. She had a work application open in this photo. There was a desk in the background. You can see different things, and it just gives us information. And that's really what we're after. What kind of information can we gather? Now, this course is not a course on physical or social, so I kind of wanted to give a high level of what to expect. We won't really be doing a whole lot of this in this course with this type of information gathering, but these are the things that you should be looking for. So if you are tasked with a physical assessment, do go out there and look for satellite images, try to get a good feel of the building layout, and also try to get a feel for who the employees are, who maybe the IT manager is, in case you're going to say, you know, I work for IT. They might ask you who your manager is. You might need to know those names. And of course, look for pictures. If you can find a good badge photo and what that looks like, you can make a fake badge, go on site, and you'll be way more passable with that badge. But sometimes they don't even look. It could be drawn in crayon. So from there, let's go ahead and talk about what we will be doing a lot of, which is the web and host. So when you get a web or a host assessment, the first thing you really should do is what is called target validation. So we're going to be targeting something on bug crowds. We're not really going to focus on this, but what we're going to do in the real world is we would validate the target. Now, there are situations where a client will give you an IP address or a website, and they might fudge it, right? They might accidentally fat finger it, put the wrong number, put the wrong letter in the website, and then guess what? You're off attacking somebody else's website. And there, if you are a podcast listener, there's a good Darknet Diaries episode on this. If you don't listen to Darknet Diaries, go check it out. There's a great episode with a guy named Rob Fuller, aka Mubix, and he talks about getting the wrong IP address on an assessment and attacking the wrong people and actually gaining access to that machine, which is a really, really big screw up on both parts, right? So you should always validate your targets. On top of this, when we're doing our web and our host, on the web side, we're going to look for subdomains, and we'll talk more about that as we get into it. But we can do that with Google, we can do that with Nmap, Sublister. There's so many different tools that we can use, and we'll cover some of the tools and how to do it. Get a little deep into that as well, especially as we get into the website of things. There's fingerprinting. We need to know what's running on a website or what's running on a host. What kind of services are out there? Are they running a web server? What's that web server? Is it IIS? Is it Apache? What version is it? Right? Are they running, what ports are open on their machines? Oh, they have FTP open. What version of FTP is open? So we need to fingerprint machines and kind of understand. But on the passive side, we're not touching any machine, right? So we're not going to be doing much scanning against a host. We just have to utilize what kind of information might already be out there. So if we go out to a website, it's on the border of active, but as long as we're not scanning it, in my book, it's still passive. So we will cover some of the passive/active side in this section, and then when we get into scanning, we'll get way more active with it. Lastly, we're going to hit heavy, especially in the beginning, on data breaches. Data breaches are the most common way when we're doing an external assessment that we get into networks. Absolutely by far. When we talk about data breaches, we're talking about breached incidents from the past that have leaked data. Again, these are like Home Depot, Equifax, LinkedIn, all kinds of breaches that are out there that have had credentials dumped, and then those credentials become available to us eventually, and we try to utilize those to gain access, or at least utilize the usernames to gain access. Nowadays, most of the time, there's not going to be an easy just scan, find something vulnerable, and exploit it on the external side of the house. So we're looking for these data breaches and this information that we can gather. And this is why information gathering and then enumeration and scanning most important by far. The better scanning and enumeration that you can do and the better information gathering you can do, the better hacker you're going to be and the better you're going to be at your job. So take these first two sections really serious. So we're going to start in with identifying what our target's going to be for this part of the section. And then we're going to go ahead and start talking about data breaches and why they're important and go deeper into that. And then we'll go off some of these tools that you see here on this list and really dive into those. So I will look forward to seeing you in the next video when we identify our target and get some information gathering started. All right, before we begin doing our reconnaissance, we have to establish a client to attack. So for this course, we're going to be utilizing a client out of Bugcrowd. If you've never heard of Bugcrowd, Bugcrowd is a public bug bounty program. What that means is there are programs on the website that will allow you to attack them. And if you find a bug against the program, you're able to submit it and potentially get money for it. So you are able to hack these programs publicly as they are part of this program. Now, the program we're going to be attacking is Tesla. So Tesla is part of Bugcrowd. Now, please do note, please double check when you're watching this course, as some time may have passed. Tesla might no longer be part of this bug bounty program. So it's very critical to make sure that you are still within scope before you attack. If for some reason Tesla is no longer in scope, just go ahead and pick a new client and do information gathering on them. You don't have to pick Tesla when we're doing this. You can just do it to follow along with me, but you're also welcome to pick any program you want. So if you go to bugcrowd.com and we go to programs, I will show you where Tesla exists. Now you can see here that they have all different types of programs in here. And if I were to scroll down and continuously, I could find more and more and more. There are hundreds of programs involved, all kinds of names: DigitalOcean, Okta, really big names, Pinterest, Atlassian. Anything that you can imagine probably has a bug program if it's reputable, okay? Any of the big names most likely have a bug program, especially if they're reputable. So here you could see what's based on reward, what's based on charity, and what's based on points only. That's how the bug bounties are rewarded. Some of them are not all cash. Some of them are just for points and for kudos, and the other ones are for charity. I'm gonna go ahead and just search Tesla. And when I do that, you can see here that Tesla comes up. Now, this is your first lesson into rules of engagement. And we're gonna talk about rules of engagement later, but it's super important to read the program details that you see here. And what we really need to do is we need to scroll through and make sure that we stay in scope when we're doing this. So we have a wildcard here. So this means that any subdomain inside of tesla.com is fair game, tesla.cn, Tesla Motors, etc. What is more important is that we stay within this out of scope. So we don't want to attack shop.eu.teslamotors.com or energysupport.tesla.com. It says you can report vulnerabilities to Bug Bounty for this one. Any domains from acquisitions, such as Maxwell. So we have to stay within Tesla. And there's a few more sites. We're not going to worry too much about that. When we get into the web app portion of the course, we're going to talk about way more detail on enumerating web applications and go into that. So for now, what we're going to do is we're just going to focus on information gathering. What kind of information can we gather from this client? So again, I'm setting my target to Tesla. If you pick another Tesla or another client, just make sure you stay in scope of that client. So from here, we're going to move on to our first video and get our information gathering started. Welcome to the email OSINT section. We're going to talk about discovering email addresses. And this is something that I do on a weekly basis. So I'm going to show you the most common tools that I use to actually look up email addresses and try to find people, and what you can do to kind of verify email addresses. So I'll show you some of my favorite tools and concepts. And this is something that I do because not only for OSINT and doing it for investigative type work, but think about sales.
if I'm trying to find a lead or I'm trying to find multiple leads within an organization, I have to figure out where the emails are, who the people I'm trying to email are. So maybe I'll Google them and say, who is the CISO or Chief Information Security Officer for this company? And I might find that it's Bob Jones. And we go look up Bob Jones and we say, okay, well, how do I get Bob Jones's contact information? Can I find it via Google? Maybe it's out there in the public, but maybe we have to dig a little deeper. Maybe we have to kind of do some guesstimation and see if we can figure it out. So that's what we're going to do today is look at the email addresses, formats, and try to determine if we can find some emails. So let's go ahead and move over to the Kali Linux machine that I've got. And the first website is one of my favorites. So hunter.io. You just come to hunter.io. You get like 50 or 100 free searches a month. I don't remember what it is. It's a fair amount. You can come here and basically just type in a company name. So like say I want to type in TCM Security, TCM-sec, and you can see TCM Security here. We get one result on the email address. So we'll click it and see what happens here. And looks like we have like an info@tcm-sec.com. It tells us, hey, there's 5 sources that identify this. So we see tcm-sec.com. There's an about, blog. So this is where they're finding it, okay? A better example, maybe something that has more users, like Tesla. Tesla has 468 users. If we come in here and we look, well, we can see that they have a pattern identified here. So their pattern they're identifying is first initial, last name at tesla.com. And that's really what we want to see. And then we can gather email addresses here if we want. But say like we knew Bob Jones. Again, going back to that example, Bob Jones. So maybe Bob Jones works at Tesla. Maybe his email would be bjones@tesla.com. So it's something to think about. Now, we can sign up and get actual information here. You should be able to sign up with a Gmail account. Sometimes this does not work depending on the country that you are in. So be cognizant, you might have to use a different email address, but I just tried signing up with a Gmail account that I have on here and it worked just fine. So I'm going to go ahead and try to log in. I'm going to sign in with Google with what's already here and just now I'm logged in. So we can go back now and try searching Tesla again. And you'll see that the results actually come back. So we get information here now. We get, let me make this a little bit bigger. We get information as to, okay, here's the vice president. This is the vice president's email address. Project development manager. Maybe you want to talk to somebody in human resources. So you can click here and go to human resources. And then here are the different human resources emails that are here. So, and then the sources that they found these email addresses. So this isn't a particular person in HR, but it's still human resources email addresses. So this looks like it's probably for Hong Kong. This is for Berlin. This is Gigafactory. So they have different email addresses based on where they are. Now, if you looked up TCM Security here, you're really not going to find much on us because we don't have a ton of email addresses out there, but I think that we can find more in other ways. Now, so we only get so many usages here. We'll just keep thinking about this as we move forward. So hunter.io, great resource. They have plugins if you want them. I think it's a fantastic place to look. Phonebook.cz is the next resource I want to show you. This one is fantastic. Let's start with tcm-sec.com and see. So we're going to go tcm-sec.com and we're going to search email addresses here. So they do domains and URLs as well, which I think is awesome. But let's just search for email address. See if anything comes back. No results. Okay, that's okay. Let's try Tesla and see what comes back there. Okay, a lot more. So we get quite a few email addresses. We could see Elon Musk all over the place. We got Elon-Musk, Elon, we've got eMusk over here, and we get a ton of emails. Look at this. So what's nice about this is we can sit here and try to identify what the possible email addresses are. So again, first initial last name looks like it's showing up quite a bit. Outside of maybe like the Elon Musks of the world, we're getting a bunch of mostly first initial last names in here. So I think that's pretty spot on with this. The Other thing that we can do is we could utilize this list. Say we're trying to do something called credential stuffing, which we'll talk about in the next section, actually, when we talk about breach credentials. But say we're trying to gather a bunch of usernames and test and see if we can log in with those usernames anywhere. Or maybe password spraying, not so much the credential stuffing, but password spraying, where we take all these usernames and we just throw it at a login form and say, hey, summer 2020 exclamation point. See if that logs into any of these accounts, and you would be surprised. It happens quite a bit. So this is valuable information, even if we don't know exactly. Maybe we're not just hunting for one email. Maybe we're hunting for an entire domain. This is a great way to get free entire domains with a quick copy and paste capability. Like we have the Tesla here, we can export the CSV from hunter.io, but you only get so many results that you can export into a CSV. Here you get a bunch. There's no guarantee these are all valid, but it's still information. Information is what we want. This is all we're trying to gather, is as much information as possible. So these are all potential email addresses for Tesla.com. I think it's a great resource. Now, we could also use something like Voila Nobert. Now this one, you can get 50 more leads for free. I'm not going to show you. It's the same kind of deal as hunter.io. They're showing you how to utilize it here. Basically, you can just search for people and see to try to find their email addresses. There is one I want to show you that I do use and I have quite a bit of success with, and that is called Clearbit. And Clearbit has to be used in Chrome. So I'm going to bring up this here. Clearbit has to be used in Chrome. So you can download the Chrome extension for Clearbit. And all you would have to do is go to Google. Let me log in really quick. And then I'm going to just select the free account. We get so many searches, 100 emails a month. So basically, you're going to search for Clearbit Connect, and you would just say, hey, Clearbit Connect. I'll put a link down below, by the way. But Clearbit Connect is awesome. You'll see why here in a second once I authorize this. Okay, we're going to come down here, acknowledge, probably give out our firstborn. And then now we're going to say, hey, I want to find emails. And here's all different kinds of things that we can sit here and search for. You can see TCM Securities in here. These are some searches that I've done. These aren't any clients of mine. These are just searches that I've done in the past, maybe looking for information or looking for possible leads or anything. So if I come in here and I say, hey, I want to look for TCM Security, you could type that in. I'm going to just click on TCM Security. And look what it discovered that the others didn't. It discovered me. Okay, and if I click on me, look, it says heath@tcm-sec.com. Where did that come from? And then look, it has my LinkedIn right here as well. That's amazing. That's awesome. And it says here, you can email Heath. Just click this button. And then it's also got Rizwan. Rizwan's on my sales team. Look, it's got Rizwan@tcm-sec.com. What does that tell you? That tells you that we're using a first name basis for our email addresses. It's awesome. Now let's come in here and maybe we want to look at Tesla. Maybe let's try Tesla one more time. Maybe we're looking for the CISO of Tesla if Tesla has a CISO. You could come in here and look, like Elon Musk is right here, obviously CEO, but you could come in here and maybe go by role, and they have different roles in here. So CEO, let's see if we can find any sort of CISO. I don't see one, but I do see information technology. So maybe we can find somebody in the information technology department or IT department. And then here we go. We've got quite a few IT people. Here's a CIO. This could be somebody of interest that we might want to reach out to. And we could just scroll through this list and find people. So say we want to reach out to the CIO. Just click on this. We get first initial last name, just like we thought we would. We get this person's LinkedIn page. We get their location, website. This is awesome. Awesome. So I typically will start with a Google search. If I'm trying to hunt something down, I will start with a Google search. I will say, who is in this role at this company? If I'm looking for a specific person at a company, then I will go to phonebook.cz or hunter.io, try to identify the formatting of the email, and then try to find that person or guesstimate that. Once we get to that point, I try not to burn through these Clearbits unless I need to, but Clearbit is very good at identifying this. Once we get to that point, we can take this email, say like this email, or we'll even try a different email. I'll show you a couple. But we could take this and we can go try to verify this. So there is a website called Email Hippo. you can go to tools.verifyemailaddress.io, and all you have to do is type in an email address here. Sometimes you can get false positives if they're good or bad. Here, I typed in this email address a couple times and just got a bad result. This is an email address that does not exist. Now, let's try an email address that we saw, info@tcm-sec.com. See if it works. Result is okay. So it says, yeah, this email address works. So we're verifying that this is up. So say that you get somebody and you see that they have a potential email address, you can come here and try to verify it first and see if it works before you go fire off an email. You don't even have to fire off an email. You don't have to do anything or interact. So this is the benefit. Like if you're from a sales perspective and you're doing OSINT here, this is the benefit of not having to email, waste your time, get it rejected. You can come in here and just validate. If you're doing an investigation, you don't want to interact with the person or company that you're investigating. You want to come in here and just verify without any interaction. This is the way to do it. Same thing with this website here, emailchecker.net/validate, email-checker.net/validate. Say, hey, checking the email. I put the same email address here. You can see it says bad. We could try again with info@tcm-sec.com and see if that works. And it says okay. So again, this is doing a great job. There are possibilities of false positives. There are so many searches that you can do per month on these, I do believe. They have APIs, which is nice if you want to automate this or script this out. But I think this is fantastic. This is great stuff. Now, there are plenty of other ways to verify email addresses. In the next section, we'll talk about that even more as we talk about breach data. Because if somebody shows up in a data breach, guess what? That email address has been used in the past. If you look at something like a Have I Been Pwned, which we'll talk about in the next section, and they show up, guess what? That person's email address has existed. So we're trying to verify if an email address exists, who that address might belong to, etc. Now, this has been from a business perspective. Some of this hunting down of emails may be more difficult to do if you're trying to find a specific individual. That's where breach data comes into play in a lot of this research. And what I'm going to show you in the next section, we'll try to hunt down individuals with maybe having loose pieces of information like a name or a username or something along those lines. Breach data can come in handy very, very well. So this is kind of scratching the surface. Now, there's one last thing I want to show you, one last little tip and trick. Do not underestimate forgot passwords. Do not underestimate them. Let's go to Google, for example. Right now, I am logging in under an account that is please don't hack me, sir, please. So it's please don't hack me, sir, PLZ, I do believe. I'm going to go ahead and try hitting next on that. Okay, so first of all, it said, hey, welcome. And what does this mean? This means that we have a valid account here. That's great. This is validating that this Gmail account exists. Here's something else. We can use this to tie to potentially another account or help validate. Say we know that this email belongs to somebody that's harassing somebody else. We don't know who this person is. They're using this spoofed email, but maybe we have a hunch or maybe we don't. Maybe we just want to try to get more data. You can come to forgot password and it's going to say, what's the last password you remember using? I don't know. Let's try another way. You come down here and it says, hey, let me make this bigger. Google will send a verification code to H. And it says, look, it shows you the rest of the digits here. And then at TC here. That would give you a pretty good indication if you're tracking who your subject is, that this email could tie to somebody else. Look, this is heath@tcm-sec.com. Okay, so this email belongs to me. This is tying back to me. Now you have another point here. So if you knew about this email address and now you have the link, the connection to guarantee that this person, this is evidence right here. Say you were doing something, which we'll learn about again in the next section, where you're looking through breach data, you find a username that matches this email address and also matches this email address, but people can reuse usernames. There could be multiple people who use the same username. So you need to verify or some link. This would be a proof of a link between those, a pretty strong proof if you ask me. If you can say, hey, I identified 2 email addresses with the same username, I did an account recovery, came in here and saw that this had this same first character and first domain name, I think that's a pretty strong correlation. So Things to think about, wheels to be spinning. Try to identify email addresses in any way possible. We'll cover this more in depth in the next section. And I'm really excited because password hunting is one of my favorite things. So let's go ahead and move on to the next section when we talk about password OSINT.
Okay, so I would like you to go out to github.com. And then once you're there, go ahead and just do a /h Maverick Adams, HMAVERICK Adams, and hit enter. And you can see me in my snazzy photo here. But what we're after is I want to show you a tool that I wrote called Breach Parse, and we're going to walk through what it does. Now go ahead and click on Breach Parse, and you're going to see a bash script here and a little bit of a description. So you do not need to download this. Let me preface with what we're doing here. This magnet link, you're going to need a torrent, some sort of uTorrent or BitTorrent, and you'll need to download this. And it's also something along the lines of 44 gigabytes extracted. It's a huge file. So you don't have to do this. You can just watch and follow along. You are more than welcome to install this on your machine. I'm going to show you what it looks like. So I'm going to go out to my applications and my files here. And then I have put this into my opt folder. So if you come into opt here, and then I've got breach parse. If you come into this breach compilation folder, which is what we'll download, you're going to see that we have data here. Okay, so this data has a bunch of different data. It's got emails starting with 0, 1, 2, 3, 4, all these different ones. What's living inside of this is, if we can display it, is emails and passwords. Now you see these ones have weird symbols inside the emails, but there's a bunch of emails and passwords in here, like somebody at yahoo.com and their password is 123456. Well, these passwords are coming from credential dumps. So we talked about it earlier about thinking about the Equifax or the LinkedIn breach or Home Depot, all these big breaches that happen, credentials get dumped out. And guess what? They show up on the dark web, and eventually they show up in these lists. So we utilize these lists, and we've got, if you click into this, just hundreds of files here, and again, 44 gigabytes. So what I did was I built a little tool that can search through this data and pull down names. So we could take a quick look at the tool and what it does. But basically what it does is you just put in the syntax, you search for something like @tesla.com, and then you specify, tesla.txt. And it's going to search through all of these files for @tesla.com. If you're more interested in the code behind it, you're more than welcome to read the code in here and see if some of the items that we've covered already with the bash scripting and the Python scripting kind of ring a bell. So what we're going to do is I'm going to come ahead and go into the terminal and make it a little bigger. And then I'm just going to change into that opt folder, breach parse. I'm going to run breach parse. So breach parse here. And what we're going to do is I'm just going to say @tesla.com and then tesla.txt, and that's going to run. So again, you do not have to install this. This is only for visual purposes. I'm going to show you in the next video another way to do this. So this is going to run through. It's going to take a minute here, and it's going to grab everybody's username and password that says tesla.com and the username, and then it's going to have all the passwords. And we're going to be able to decipher things from this. So I'm going to let this run, and as soon as it's done, I'll come back and we'll talk about the results. Okay, the results are back. So this breaks it down into 3 files. There is it's cat Tesla. There is a master, passwords, and user. So the master has the username and password, and then the users file has the users, passwords has the passwords. So I'm gonna actually gedit the Tesla master.txt, and let's take a look at this. So from here, we don't have a big list, surprisingly, for a company the size of Tesla. So what happens is people utilize their work credentials or their work emails, and they log into websites and probably shouldn't be using their work emails for, and we just use it to our advantage. So what we're after not only these usernames, but we're after these passwords as well. So we see these usernames and we see these passwords, and I like to look for repeat offenders. I like to look for the syntax as well. Remember, we had first initial last name, but we see first name dot last name here. We see possibly, just a single name. There are different types of things in here. So Nick at Tesla.com as well. So, it's changed up. I think nowadays it is first initial last name, but maybe in the past they used first name dot last name and then moved to an easier format. Or vice versa. They started first initial last name, they got too big, then they had to do first name dot last name. But again, what we're after here is potential repeat offenders. So look at this shark at Tesla.com. It got popped twice. And the password is very, very, very similar. So if I were to attack Tesla.com through a login interface, I might spray this username with this password and this password. That's what we call credential stuffing because we already know the passwords. And then I might make some modification of capitalized letters and non-capitalized letters with DADE because 907 and 814 appear to be consistent. So I would alternate capitals and non-capitals here in lowercase and just see maybe if something sticks. So this is something that's interesting. This user down here, 12345, 12345 star, probably not going to get in with that on a company like Tesla, but you never know. But this is what we would do. We would take the usernames and we would throw these passwords at it, and that's called credential stuffing. And then we would take these usernames and all the known usernames and we would spray passwords at them like fall 2019, like we talked about in the last video. That's password spraying. So this is an important and very, very critical part of information gathering, is gathering these usernames and these credentials. Right off the bat, you want to identify those with your targets. So this is kind of what it looks like. This is what I do during every assessment, and hopefully that makes sense and that works into it. In the next video, we're going to go ahead and just show another method and start thinking again about these credentials and how they can be utilized. And then we'll do some other information gathering as we move on and learn some techniques and how we can get information on a client. So I'll see you over in the next video.
Okay, let's talk about hunting breach credentials and let's get hands-on. Now, before we get started, I know I stressed this in the beginning of the course. I'm going to stress this again. What I'm going to show you here could change. Now, I released a course about a year ago, which was on ethical hacking. We talked about breach credentials, and I utilized a website called WeLeakInfo. WeLeakInfo was then eventually shut down, and I got all kinds of emails saying, hey, this is shut down. I don't know what to do. There's more out there, okay? There's always more out there. What I'm showing you is the methodology. I could show you on a specific website, which I'm going to do. That website could go down tomorrow. We never know. But what you need to retain is the thought process and the methodology behind what's about to happen. From there, you could take that and utilize it elsewhere. So if a website does go down, you still have the same thoughts, why you're doing it, and why you're thinking about it. So let's go ahead and move over to a website now. So I want to take you to a website called Dhash. Now this is dhash.com. I do not expect you to be able to follow along at this point because this costs money. Okay, it's $5 for a week. It's $150 for a year. This is only, it used to take credit card. They only now take Bitcoin, I do believe, or some sort of cryptocurrency. Absolutely worth it, in my opinion. Even get a week. Get a week, see if you like it. It's amazing. There's going to be tools I show you later on in the course that will go through and we can do it locally, like the one I just ran in the last video. I ran breach parse, right? This is something that I put together and set up, and it's free, but the database isn't maintained. It's a slow search. I don't get the results back as instantly, and I can't tie it to as many data points as a website like this can. I think this website's great. Now let's talk about what Dhash can do now that I'm logged in. We have the ability to search by, let me make this a little bit bigger. We have the ability to search by email, username, IP address, name, address, phone number, VIN. Okay, think about this. Say we know a email address. Okay, we know an email address. Say it's bob at tesla.com. We're not going to search this yet. We take Bob, and we know Bob, it has an account, and we're looking for him. We search him. Bob shows up, and we see Bob shows up, and we see maybe his name, like Bob Jones or something like that, shows up. Maybe something that he's been leaked in has his address. Or maybe there was an IP address tied to the client you're looking for or the person you're looking for. This can all be identified. What if Bob has a username? It's like Bob Rocks 123. Okay, well, we can search that username in here and see if that username has repeated itself at all, which is great. We could search by password. So say Bob's password was Bob Rocks 123. We could search that password, and if it's unique enough, then maybe we can actually do some advanced searching. Like if we go back to the example from last time, like this last video, we saw this 907DADE814. We could put that into a search engine and see if that comes back to something else. Maybe that comes back to a user that is not at a tesla.com, but maybe it's like Bob at gmail.com. And then guess what? Now we have Bob's personal account, or now we have Bob tied to another email account, especially if we search by name or something that we can tie them together. We need to start being able to relate other accounts to each other. We can do that with hashing. We can do that with passwords. There's a lot of things that we can do, and we want to start tying this together. As a real world example, when I am looking at an organization and I'm doing research on hashing, or I'm doing research on breach credentials, I'm trying to think, okay, first, if my client is tesla.com, I might come in here and search at tesla.com, and I might come see how many results are in here. Let's see what happens. Okay, here's George at tesla.com. George has been in a shared data, so there's no actual any details here besides a potential username, a name, email. Okay, same thing with safety. We'd have to scroll down and see if we can find something that, okay, here's Adobe. Now Adobe will have there's actually a Bob at Tesla. Bob at Tesla has a hash password here. Okay, so now we can say, well, first of all, we can go see if we can figure out what this hash is, which we'll talk about in a second. We can also go and say, okay, Bob, does Bob exist anywhere else? Does this hash exist anywhere else on this website? Can we tie it to another account that maybe, even if we don't crack the password, then we can say, okay, this ties to Bob at gmail.com. So like I would note this down and I would take this and copy it. So from a real world example, I would take all the data that I see on this website. I would collect all of the passwords, all of the usernames, everything. So like Tesla 9, all of this. I want to know what the passwords are. I want to know who the people are. I want to know all the data. Because if I could start finding patterns, if I could start putting things together, maybe I can even relate these back to their personal email accounts like we're talking about. And then I can see password patterns there or other passwords and just start tying this down. Because my goal is to break into an organization. If I'm doing a pen test, my goal is to break into an organization. So I'm going to take that data, and if I can find other passwords related to a personal account, I'm not going to go attempt to break into a personal account, but I will take that data and I will put it together and maybe try to break into their work email account with those passwords of that information. This can tie to an investigation as well. If you're hunting down an individual, you're trying to tie them to other accounts, this is incredibly useful. If you can find their data in a breach database and have a password, and that password's unique, you can search it, maybe find them somewhere else. You find an IP address, you find a name. There are often IP addresses in here, which we can tie to a location possibly. And see, here's that 9078 or DADE 814. We could take this and maybe search it and see if it comes back anything. Who knows? Shark at Tesla. Okay. Shark at mail.ru. Look, this is a new email address. We didn't know about this one before. And look, it does us a favor. We searched DADE, but here's the capitalized. We didn't search for capitalized. We're not searching specific. Okay, and now we're getting more information. Look, here's one for Dropbox. Okay, so it tells you where this is coming from and how you can tie it in. If we can get any sort of name out of this, any sort of anything, that would be amazing. We can get a person's name or IP address and we can start tying them down. But when you're doing different searches like this, you need to start almost, like in the investigations where they have like the the red yarn and it's going from one pinpoint to another, you kind of have to zigzag that back and forth and really try to tie this down. And you'll see that when we get into reporting, how you might take one individual and really just see like a password tied to an account, tied to this. And this was the exact methodology that we took to get to that point. Because when you write a report, you want to make sure that the investigative person, or say you're handing off to the police or whatever, you want to make sure that the person that is doing what you did, or they can replicate what you did with ease, and there's no question about it. So this is some of the searching that we can do. Now, if we come to dehashed, again, we can come here and we can search by email, username, name, anything. So you can put your name in here. I mean, if you want to search on here, I think it's great. You can come through here and just search for your name. Let's go back. Let's search Tesla again. I saw a hash in there. The Adobe hashes are kind of interesting. They're not the easiest to pick up, but let's see. Let's find this Adobe hash. So let's say we get a hash like this. We could try to identify what this hash is. We can try to crack this hash. We can see if it's been cracked somewhere else. This hash, as of right now, we have no idea. But we know bob@tesla.com. We can maybe paste this in here first of all and see if it ties back to anything. And there's 22 results back. You know, I would probably be looking for somebody that has this password with the name of Bob. It's probably not going to be like a Brett or a Michael. You know, we might want to see if we can find another account somewhere else, but these are all tying down to a hash from Adobe. So depending on how they were hashing this data, we might not find anything else of interest. But you can see all the things here, all the different opportunities that are here for us to just do research and tie down information. Now we can go to a website called hashes.org. And if we come here, we have the capability to actually try to search for this hash. So we could search hashes and see if we can find it. So you can come in here and just paste it. And again, it doesn't do a great job, in my opinion, with the Adobe hashes. Sometimes they crack, but a lot of times it says it can't find them. Oops, there we go. Let's try hitting a search here. Okay, so it says not a valid hash. Now, if you put this into Google as a search, you can see it didn't come back with anything either. So we want to make sure that when we're searching this, you know, we try all options. There is an Adobe database that if you do put in a hash and it does show up, there's a GitHub Adobe database that will actually show up here. So with that being said, this is kind of what I want you to start thinking about when we're hunting down breach credentials. How can I take a person or company that I'm looking into? So if you have a company, you can just go at companyname.com or .net or whatever it is. Search in here, see how they show up. If you have a person, maybe a personal email account, if you can find that person, if you know their email account, you come in here and say bob@gmail.com. Maybe you don't know what their email address is. Then maybe you come here to the main page, you go, okay, I'm going to look for a name. I'm going to look for Bob Jones and search for that. And then you start taking this and trying to find the patterns. If you know Bob lives somewhere, maybe you could find an address for Bob, or maybe you know Bob lives in like Arizona. You could search Bob Jones and see if Bob shows up, and then kind of take it from there. And there is some search operators that you can utilize. You can see Bob Jones is taking forever. You can put this in quotations and search it again, and kind of narrow down your results here. So if we click on this, you could see like, here's a name of, we got a lot of results, but here's the name of Bob Jones. This is a very common name. So, but you could see like, if we're trying to look this down, we can start searching and adding operators in here and trying to see if we can figure out to tie a username or something to them. So again, get your wheel spinning. Don't rely on just dehashed, but just rely on thinking about this. This is the thing you should be thinking about. Again, dehash could go down tomorrow. But if you're thinking about it in the way that the credentials and the information can be interwoven, remember that red yarn again, that's really what I want you to take away from this. So we're going to do another video on this. I'm going to show you some more, I guess, tools that are out there and some other things that you can do, offer alternatives to this, and then we'll wrap up this section. So I'll catch you over in the next video.
Okay, we have reached the end of part 1. I am again going to link in the description below the link to part 2. So go ahead and click on that if you finish this, and we're going to meet you over in part 2 of the video.